Oh, hello. See, we have some people already here. Welcome back, everybody. Give people a little extra time to get situated and people come in to check out the stream. Morning, everybody. Morning, Anthony. Good morning, Alyssa. Morning, Dylan. Oh, man. Hi, everybody. Oh, it's Leo's birthday. Well, happy birthday. Thanks for joining us. Hi, Erica. All right, well, I think we're going to get started. So I have a lot of cool stuff that I'm going to show you today. We're going to be talking about electricity and motors and batteries. So let's start with electricity. What do we use electricity for? So what do you use electricity for in your day-to-day life? Television, yeah, television, tablets, TVs, phones. So all sorts of things. How do we get electricity? So where can we get electricity from? I mean, I have a big hint. The sun, yeah, the sun is a great source of electricity, and we get it from power lines. Yeah, so power lines are connected to power plants and all sorts of things. The sun, solar energy. There's also hydroelectric, and my favorite, geothermal. That's a great source of energy. Yeah, coal. Yeah, batteries. Batteries are another source of electricity. So I have some batteries here. I have a lot of different batteries. First, I have AAA battery. There's the small one. You can get batteries even smaller than this, but this one's really common. So that's the AAA, and then this is a AA, a little bigger. And then we're going to skip over. There are C batteries. I just don't have any. This is a D battery, and this is a 9-volt battery. They call it a 9-volt because it has 9 volts. These other ones have 1.5 volts. So this is a special kind of battery. And of course, there's different kind of batteries in different devices. So for instance, a cell phone that uses a different kind of battery, rechargeable battery. And there's, for instance, computers, those rechargeable computer batteries inside laptops and stuff. And then there's special batteries for things like cars and things like camcorders. If I can get this battery off, there you go. So that's another kind of battery. But all batteries have something in common, and that is they use chemical energy, transform that into electrical energy. So there's chemical reactions that happen inside a battery that allow electric current to flow. And then we use chargers to recharge rechargeable batteries. So inside a phone or rechargeable batteries, we can plug that into an electrical outlet and get electrical energy from the power lines to recharge batteries. Every battery also has a positive side and a negative side. So this bump here on the D cell is the positive side of the battery, and then this flat side is the negative side. And the reason they have that is batteries, the way that they use electricity, the way they give out electricity is in one direction. So I have a picture here that I drew right here. Get over here. There we go. So it's my skills of an artist. I'm clearly an expert. But you can see, oh wow, I can get really close. So right here, there's the battery, and then at the top there, that's the plus sign. So that's the little nub at the top of the battery. That plus sign means positive, so that's the positive side of the battery. And then the bottom is negative, and then I have wires here, and I have a pen that I'll use to point. So there's wire at the bottom, red wire at the top, and then the little arrow shows you how the electricity is moving through this circuit. The battery gives electricity and it goes through the circuit, and then this over here is a device that the battery is powering. So I'll put that over here. Inside devices like a TV remote, you may have noticed that if you have to put batteries in there, there's little springs and places to put the batteries. Oh, wow. People are made a light bulb to turn on in science class this year. That's really cool. Made a hair bow out of cardboard paper and tape, like you said yesterday. That's really cool. Anyway, the springs are where the negative side sits. So this is for AAA batteries. I'll put a AAA battery in there. You can see the spring gets pressed down by the negative, the minus side of the battery. Now, told you that story to tell you this one. Circuits are what let electricity flow through different objects or devices. And I have a motor here. So there's the motor. It's a little hobby motor. And I have two wires attached to it. The red wire is no, that's the black wire. The black wire is negative. The red wire is positive. But the really cool thing about this motor is that it can go in two different directions. So I will demonstrate with these batteries that I have here. Each one of these batteries will be able to power this motor. So I'm going to take this red wire. First I have to figure out how to have three hands to hold this thing. But if I take one wire to the positive side and another wire to the negative side, oop, there it goes. It started to move. This little AAA did not give me enough power. It's probably running out of energy, but you can see the motor's trying to move. If I try to use a AA, then that might work a little better. There we go. So the battery is giving electric current, and it's going through the wires into the motor, powering the motor, and the motor spins. If there's no wires contacting the two sides of the battery, the electricity doesn't flow through. And of course, I can use this D cell to do the same thing. There we go. And I can use 9 volt. The 9 volt's a little different because the contacts, instead of being on either side, so the positive and the negative, they're right next to each other. And so I put those together, and there you go. So this little thing lets me hold one wire in place. That's why I have a rubber band on here. So what I'm going to do is, what I did there was I took the black wire and put it on the negative side, the flat, whoa, battery's rolling around. Put the black wire on the flat side of the battery and the positive wire on the little nub of the battery, and that made the motor spin in one direction. What do you think would happen if I tried the other way? What if I put the black wire on the nub on the positive side and the red wire on the other side? What would happen to the motor? Would the motor work, or would it do something else? Would it break the motor if I tried to reverse the current? Yeah, I can assure you it won't explode or something dangerous like that. It'll spin the other way. I don't think it'll work. Well, let's see. I'll use the D cell because the D cell's really big. So before I was taking the black wire and doing this, like that. And that made the motor spin clockwise. And now the motor is rolling away. So I'm going to hold down one of these wires. So this is the normal way. That's the normal way. So it's going to go, oh, it's not going to work. Technology. Okay, let's see. This is the normal way. There we go. So it's spinning clockwise. Now I'm going to reverse the wire. So I'm going to take the red wire and put it at the bottom. And then I'm going to take the black wire and I'm going to put it at the top. Okay, here we go. Oh, come now. Oh, there we go. It works. But what's really cool is it's spinning the opposite direction. So what happened there was because the wires are reversed, the motor got the electricity going in the other direction. It always goes from positive to negative. So if the battery is flipped the other way, then the electricity goes in that direction. So that's why if you put batteries the wrong way in a TV remote or something like that, the remote won't work because it wants the electricity going in one direction. And if it's going in the wrong direction, it doesn't work. So before I go, I'm coming close to the end of my time. I want to show you something really, 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 really cool. I have the D cell here, whoops, and I have magnets. And I'm going to take this piece of copper wire and I'm going to put it right on top of the battery like this. And what happens here there is a wire, but there's one wire, the copper wire. It's just a magnet and a battery and wire. And what's happening here, here's what's happening. This is just, oh man, this is cool. Okay. So the magnet, I'll get to the magnet in a moment. The battery is giving electrical energy into the wire. The wire is copper, so it's not magnetic. But whenever there's electricity going through something, there's always a tiny little magnetic field. So there's always a little bit of magnetism. So that magnet is pushing on the wire and making it spin. And it's spinning clockwise because that's how the electricity is going through it. So thank you very much for joining me on, oh man, it's really spinning now. Oh, all right. Well, thank you for cool. Thank you for joining me today on Curiosity Corner Live. And check back again at 3 o'clock because there's some more cool stuff that I'm going to show you. But here's your challenge. If you have this kind of stuff at home, you can get an adult to help you make a motor like this, and you can try different ways that the wire is set up. And you can make a simple motor at home. But if you don't have that kind of material, you can also get an adult to help you and look around your house for things that use electricity and think about how the electricity is going through them. And share your results on social media, and I will come back at 3 o'clock and talk a little bit more about electricity, and I'll give a preview for tomorrow's installment of Curiosity Corner Live. So thank you very much for joining me. My name is Andy. Bow ties are cool. And stay curious. and I'll see you next time. Bye, everybody. Oh, if I can find the button here. Boop. Ding.